So, in the meantime, let's proceed. Let's proceed. Um, okay. So what we have done up until now, we completed pandas, we completed matplotlib, we completed numpy, and I gave you some base introduction of scikit-learn, and we did some our like first modeling or something, right? This is what we did. Correct? So, okay. I told you, okay, first of all, I explained you why do we need scikit-learn, right? Um, in basically machine learning is very vast in Python in general. There are so many different sort of libraries and so many different ways to actually reach and try to solve the problem. Okay. And I have already explained you that there are primarily two categories, right? Um, okay. So, okay, let's try to update it here itself. Why scikit-learn, right? So there are primarily two categories, which is one, it is mostly you'll see classification problem, okay, uh, and regression problem. Now these are the major ones, okay. A large number of problems will fall into classification problem or a regression problem, and then third one is clustering problem, okay. uh, I think in my first class itself, I explained what is classification, what is clustering, what is regression. But you guys can answer me one by one. So what is classification problem? 10, 9, 8, 7, 6, 5, 4, 3, 2. And no one knows, man, what is classification problem. Okay. Classification, okay, categorizes the object into classes, right? So can be thought, correct, can be thought into two separate problems, right? It can be a binary classification or it can be multi-class classification. Okay, binary classification as in when you are dealing with like two sort of classes, male, female, boys, girls, so on and so forth, right? Multi-class classification can be what sort of breed of a dog we are dealing with. Is it a Labrador? It is a Doberman? Is it a Pomeranian? And so on and so forth. That can be considered as multi-class classification. Okay, so mostly these types of data are labeled. Correct? Okay. What is regression? What is regression? Hmm. So that is the most correct one. Mostly statistical process for estimating relationship between dependent variables. Okay, often called as outcome or response. That's how we define it. Okay, that's how we define it. Um, and it also correct, and it also deals with independent variables. Okay, so often called as predictors and so on and so forth. Okay. Um, Now, what are dependent variables? Okay, a variable is considered dependent if it depends on an independent variable. Okay, so that can be considered as dependent. For example, something depends on time, something depends on space, and so on and so forth. Okay, independent is time itself is independent of any other stuff. Correct. So that is called independent. A data which does not need to depend on anything, that is called independent. The most common form of regression is actually linear regression. Okay. Uh, in which basically we draw one line and try to actually estimate things. Okay. Um, Now, if you remember last class, I showed you this estimator, right? And this estimator is also used to determine what sort of algorithm, machine learning algorithm we are supposed to use. Okay. So for example, if we start, if let's just say we have more than 50 sample, are we predicting a category? And if it says no, we are not predicting a category, then it says, are we predicting a quantity? Okay. Are we predicting a quantity? And if it says yes, so mostly regression model deals with some form of quantity. Okay. That's what it is saying, right? At least based on this. That's what it is saying. That's what it is saying, right? So you need to keep this in mind. Okay. And what is clustering? What is clustering? Correct. Grouping similar objects which are having similar properties into one basket. Like that's how we do clustering, right? Once you know what kind of problem you are working on, okay? So you use that estimator, you use that sort of mapping, you will eventually realize yourself. But once you know what kind of problem you are working in, okay, there are pretty much similar steps that we'll be taking apart from like choosing the right model. Okay. And then we'll basically choose a right model and do some prediction. But for example, these steps that I said, for example, get your data ready. We need to pick a model, fit the model, evaluate the model, improve through experimentation. These will be pretty much same. Okay, these will be pretty much same. Okay. Uh, just telling the Blackbucks they can't share assignment if they don't have heart disease data set. They need those data sets. Okay. If you are trying to create a machine, sorry, I thought if you are trying to create, okay. Now we figured out how to pick our model, right? And now we'll be going ahead. So how will be doing? So throughout this scikit-learn process, even though I gave you a rough idea how to do it, how you will approach it. So first of all, obviously, you'll practice what I have set here. I'm telling you about, okay, which is like scikit-learn and everything. Secondly, go to Stack Overflow, search for any questions and answers if you have any doubts. Thirdly, use ChatGPT, but use ChatGPT with discretion because ChatGPT is mostly wrong in a lot of questions. It does not always give you right answers, but it is good for code explanation. So some parts, if you're not able to understand in terms of code and you want to dig deeper, ChatGPT can help you a lot. Okay. Um, Okay. So yeah, so seems like they have also given you heart disease uh, problems. Okay. So what we did last time, we basically got heart disease. Okay. Then we tried to create a feature matrix basically, right? Um, and I said that, so, okay, there are few explanation that I rushed. So I'll try to make it a bit slow. Okay. In this problem also, we are using heart disease data set, right? Yesterday, I already showed you. This is what we have already seen countless times now. We use pandas to read CSV, correct? Um, and then you can look at the data set however you want. You can use head, tail, or whatever. Okay. If you would see this data set, okay, for example, um, for example, okay, if you would just see this data set, okay, okay, something like this. If you remember head, it gives us first five, right? So if you see this data set, you will see that each row is a different patient, right? Each row is a different patient with different sort of data, different sort of columns, okay? And then we have, I mean, except the target. The only target is something like which is very common, okay? Other than that, it has pretty much similar sort of things, okay? Let's try to look at tail. Hmm. Oh, my keyboard is not working or what? Okay, give me 1 minute. Seems like my keyboard is not working. Okay, so if we have tail in here, okay, you'll see we have 0, 0, 0. So in the last target column, you can see that we have either 1 or we have 0. We have either 1 or we have 0. Right? That's what we can see. Um, Now, target column basically in here indicates that if someone has target 1, if something has target 1, okay, if something has target 1, that means they have heart disease. Okay, okay. Something has target 1, that means they have heart disease. And if the target is 0, that means that they don't have heart disease. We have seen this data set over and over, but I'm explaining it to you again. Okay. And the rest of the columns are often called features. Okay. Rest of the columns are mostly called features. Okay. So all of these columns that you see are what? Are features. Okay. Now, it is common to actually save features to a variable X and then Y basically, so we just divided it in X features to build a predictive algorithms, and then we try to predict label Y. Okay, so it is very common practice to do this, and henceforth in here you see that we try to create features. Okay, henceforth you see that we try to create features. So we create X all the features of column. Okay, and we just drop target because that is our, that is what, that is the column that indicates whether something has someone has a heart disease or not. Okay, and what I said, except this column everything is feature, hence why we drop that. Okay, except this column, which is basically classifying if someone has a heart disease or not, everything else is a feature. Okay, and then we create Y, okay, which is our label. So except, so rest of these are what, features, but what is Y? Y is our target, that is label, right? And I again write it here, 0 no heart disease, 1 heart disease. Okay, now what? um we can, so there are so many information that we can drive through it, which technically we didn't do yesterday, but there are so many information that we can drive through it here. Okay, for example, assume we want to check the head and the value counts of the labels. Okay, so it says we have 165 ones and we have 138 zeros. Okay, okay. Now we have read this, that it is usually a good practice to split data set into training and test set. Now quickly give me answer how we split. What is the ratio to split? Guys, what is the ratio to split? Right. So ideally it is 80-20 sort of ratio that we split in. Okay, but it can range. It can range. It is not 100% um thing. It is like you can do 8 is to 2 as well, 7 is to 3 as well. Okay. Correct. You can do, there are lots of combination that you can do, but the idea is that you need to have this split properly. Okay, you need to have your test size at least 30 to 25%, 15%, depending on how large your data set is. Okay, it also depends on how large your data set is. Okay. Um, So we need to have a training data where, on which our model will train. Then we need to have our testing data on which we'll test. Okay. And Scikit-learn actually provides us, Scikit-learn actually provides us out of the box function to do this, which is this test train split. Okay. Now I can do it 0.2, I can do 0.25, whatever, depending on whatever is my use case. But a common practice is 80, 20 or 70, 30 or 75, 25 or 70, 15, 15, something like that, which is completely fine. 17, 15, 15 as in 70 is training, 15 is validation and 15 is testing. Okay. So that's how you can do it. Cool. Up until now, it's clear. Any doubts to anyone? Any doubts to anyone? Okay, no, I guess no. Okay. Then I said we need to choose the model. Okay. Now choosing the model often depends on the type of problem that you are working on. That we have already said it. It's already clear that you need to choose your model on the problem, depending on the problem that you are working with. Okay. And there are so many different sort of models that Scikit-learn technically recommends. Okay. Depending on what category of problem you are dealing with. Are you dealing with classification or regression and so on and so forth? Okay. Now, um, give me 1 minute. Okay. If we look at okay, it's not there. I wanted to show you something, but I don't see it. Cool. Um, it's okay. So, I have already shown you this estimator map. That's how we choose it, right? And since we already know in a way that we are working with a classification problem. And how do we know it? I told you us yesterday, we know it by this estimator diagram. We start, okay, then we see, do we have more than 50 data samples? Which is yes, we do have more than 50 data samples. Do we have a category? In this case, we can say, yes, we have a category. What sort of category do we have? We have a binary sort of category where we are saying someone has a heart disease or don't have a heart disease, and it is labeled, and definitely it's labeled correct. It is less than 100K samples. So we go here, and then is it okay? Then we basically look at linear SVC. So is it linear or not? Is it text data or not? If it is text data, then we go with naive Bayes. It is not a text data. We have a structured data. Okay. And hence we go with some sort of classifier. Now, in here, in this example, it says KNN. Okay. But we are saying we are using a random forest and we are free to use it. Okay. We are free to use it. Man, I seriously hate when someone actually asks for topic. Come on time, please, or don't ask this nonsense question. Okay. Linear SVC is basically in here linear support vector classification. Okay. Uh, Now there are problems that you can deal with it. Okay. In here, we don't really need to care much about it, for example. But if you are super curious, you can go into Scikit-learn and you can see it in much more detail, how and what it is, and so on and so forth. Okay. But this is basically an algorithm, okay, that attempts to find a hyperplane to maximize the distance between classified samples. That is what you need to know. And so hyperplane or so you just need to know it tries to find distance between classified samples. That for now you just need to know that. Okay, nothing fancy. This is the only thing that you need to know. We won't be dealing with this anyways a lot for now. Okay. Cool. So going back to our sklearn, we chose a random classifier, right? We defined a random classifier, and then we said we tried to get params, and we get a lot of parameters in here. Okay. These are all default parameters. Okay. These are all default settings. We can technically update these settings. These are also called hyperparameters that we can update based on how and what we want to get. Okay. Now, what we are doing after this, we try to fit into our models. So how it's done? if there are labels, so if there are labels, which is what? Supervised learning. If there are no labels, it is what? Unsupervised learning. Okay. So if there are labels, the model tries to work out the relationship between the data and the labels. Okay. If there are no labels, then the model tries to find patterns and group similar samples together. This is what is clear to us. Okay. Most of the scikit-learn modules have this fit function. Okay. Most of the scikit-learn models have this fit function where we'll take basically X parameter for features, Y parameters for is the label, and so on and so forth. Okay. In our case, we are starting by fitting a model on the training split. Okay. And hence why we are providing this X train, Y train, and so on and so forth. Okay. Now we have to use this model to make the prediction. Why are we training this model? The whole point of basically training this model is to make prediction in the future. So prediction in the future for what? For example, there might be similar sort of features. Okay, it is okay. Imagine you go to a doctor, right? You go to a doctor and then he doesn't know that you have a heart disease or not. Or if you go to a doctor, he doesn't know if you have viral fever or some other kind of fever, but he looks at your symptoms. In here, symptoms are what? Features. Okay. And what is it he wants to predict? He wants to predict if you have what kind of disease, right? So based on the symptoms, he classifies your symptoms into a disease that he thinks is most likely that you might have. And that is what we are training machine learning to do. So we are giving it symptoms and we want it to predict if the person has this disease or do not have this disease. Basically act as a proxy. Cool. I think this makes machine learning much more clearer to you guys now what I'm explaining. So I hope it is getting clearer by the day. Okay. So we trained it. We are giving it. We already gave it symptoms and so on and so forth. Okay. Now what we can do? We can make predictions. We can make predictions. Okay. So we make that predictions and so on and so forth. Now our goal is in many machine learning problem is to use patterns. Okay. Learn from the training data to make predictions on the test data. What is the test data? Test data is the future unseen data. This is why we split it. Okay. Why did we split it? Why did we split it? To make predictions on unseen data. So it is making predictions on those data which it never trained on. Okay. And that is how we know that if our model is working or not. That is how we know if our model is working or not. Okay. If you want to know, for example, okay, let's try to have it here, something. So if you want to see what our X test has, okay. You see, we have only features in here, but we don't have target. Right? We don't have target. Basically, we don't have a label. We don't have our label. And label is what we want to predict. Label is what we want to predict. Okay. We give this and we try to make predictions and we get these predictions here. Correct. Now, what happens? We have made predictions. Okay. But it doesn't make sense up until now. So each model or estimator in scikit-learn case, each model or estimator in scikit-learn's case has always a built-in score method, which is provided by Scikit-learn. Okay, it has a built-in score method, which is provided by Scikit-learn. And this method compares how well the model was able to learn the patterns between the features and labels. Okay, so it will give us the percentage or a ratio that how well this basically model was trained and what is our accuracy and so on and so forth. Okay, so the most common valuation metrics is definitely accuracy. There are some other also, but mostly we are dealing with accuracy, and that is what we want to know. So it is basically the fraction of correct predictions that we make out of the total predictions, right? Now we are checking on the accuracy. Uh, we try to calculate, okay, this is our training model. So training model, and because it also has label, it will always have 1.0. Why? Because it has already seen that data. So that is why we need to separate. No, this is why we need to split, right? On training data set, the accuracy will always be 100%, right? Now on train, obviously you always check this as well, but by default, it should work on training data set 100% for the most part. Okay. Now, how does it work on our test data set? That is the main thing that we want to, right? And we checked here and we get somewhat around 81% of accuracy. We get around 81% of accuracy. That's a lot. That's a lot, right? So, but it is still lacking some 19% or something. Okay. Now it might happen that maybe for us, okay, I'm looking at it, oh, 81% is a lot, but maybe someone's else criteria, for example, a doctor's criteria is not satisfactory enough to judge someone based on 80% accuracy that if someone has a heart disease or not have a heart disease. Okay. Henceforth, it is essential we need to increase our accuracy. Okay. So what are the ways to increase our accuracy? Okay. We need to increase our accuracy by adjusting our hypermetrics. Okay. And remember, we are getting low accuracy in here because this data is not ever seen by our training model. We were trained only on this data set, not this. So we are predicting labels in here. Okay. Now, what can we do? First of all, we can get classification report. Okay. What it does, it builds a text report showing various classification metrics, which is precision, recall, FN score, support, and so on and so forth. Okay. And I explained you what each of these are. Precision, what percentage of your prediction is correct. Okay. Recall, what percent of the positive cases did you catch? F1 score, what percent of positive predictions were correct? Okay. Support is number of occurrences. Okay. Then I also told you, I don't know where did I use it. Did I take, yeah. I showed you something about confusion matrix. Okay. Confusion matrix is what? It is to compare predictions to truth tables. Okay. Confusion to compare metrics to truth tables. Where is kappa value? Where is kappa? When did I write anything kappa? Okay, I don't know what you're talking about. Be precise when you're asking something. Okay. Finally, accuracy score. Okay. Now, we have this, okay? It is saying in confusion matrix, it is saying, because we are saying that it compares to truth table. So if y test is truth table and this is prediction, then it generates a confusion matrix for us based on that. Okay. Um, okay. Let me explain you confusion matrix a bit more. So confusion matrix basically, for example, if you have number of samples, right? And you have like there are like 10, for example, our car sort of data set, right? We had 10 data points and all, and we did some classification. The actual classification might be like 0 1 0 1 1 1, something like that. If there is 6 1s and five zeros or something like that, okay, or 4 zeros, and then we predict it. And if we get some sort of uh, like we get false negative and true positive and so on. And if you remember, I actually told you what is false negative and true positive. Correct? Correct. So in here, true positive is what? The first one in here. So in this confusion matrix, the first one is true positive. So we have 21 true positive. We have 5 false negative. We have 6 false positive, and we have 29 true negative. Now you understand confusion matrix. Anyone, any doubts? Okay. So let me add it here in the comments. So you have 21 true positive. And I hope everyone knows what is true positive, false negative, because I explained this. False negative, we have 6 false positive, and we have 29 true negative. Okay. Someone from the class start writing. What is true positive, false negative, false positive, true negative? Start writing. Write it on chat. Respond to LP. If not, then I'll explain within 2 minutes, or I'll explain. Okay. Right. So at least one statement is right. True positive is actually it is true and predicted also true. False negative is basically it was true, but sorry, basically it was actual value is false and predicted also false. True negative, correct. False negative is it was technically false, but predicted true. False positive is it was technically true but predicted. Sorry, it was technically false but predicted true. Correct. So that's what it is. Okay. So that is what this confusion matrix is. Okay. So this is just giving you more and more insights on what you are getting. It is giving you more and more insights on what you are getting. Correct. Then what we did, we basically tried different sort of estimators. Okay. Um, by default, an estimator was equal to 100. Okay. By default, an estimator was 100 or something. What we did, we started trying to iterate over it and like see, okay, what sort of accuracy are we getting? Okay. Hence why we need to experiment. We need to experiment with more and more different sort of parameters to get highest accuracy as possible. Okay. Now, there are because this is obviously this is a class, I can't show you all of the experimentation parts, but what can you do to experiment? Okay. From model perspective, you can actually tune your model hyperparameter. Okay, you can change this estimator, and then we saw a lot more configuration in here, right? We can change all of these and try to get more accuracy. Okay, but that is from what model perspective. What can we do from data perspective? For example, we got a data of 300 data points or something, but now we feel, okay, this is not enough data to actually predict. That is why our predictions are getting wrong, because the data set was not complete. It is not appropriate amount of sample size to make predictions. Okay. For example, if you guys have watched this Indian elections this year, right? So many people predicted. Let's not go on to results, but the idea is so many people predicted and they got it wrong. What are they doing? They collect a lot of data from a very huge sort of sample size. And then based on that sample size, they try to make predictions. Right? They try to make predictions. Now, what happened? The sheer size of Indian population is very huge. And if you try to predict it with low sample size, or if you have a very redundant sort of data set, it is a high chance that your prediction would go in the wrong direction. And that is what happened with the predictions that was done in this year's election, for example. Okay, a lot of, if you guys know how exit poll works, they do the same sort of psephology, has very similar sort of characteristic as machine learning. You collect a sample data size and then start making predictions on it. Okay, and that is what you need to see in here as well. So that is why if you have less amount of data, then it is likely that you need your predictions would be wrong. Okay. Then you need to do cross validation. What is cross validation? It is a way of making sure that the results you are getting are consistent across your training and your test data set, because you have to use multiple versions of your training and test sets rather than just trying luck. Okay. In here, just because I want to teach, okay, I'm not using a lot of different combinations. But when you go in a production ready setup, you need to try out different combinations as well to do cross validation. Try different parameters, different hyperparameters, and so on and so forth. Okay. The only exception for cross validation is time series data. Okay. The only problem with cross validation is time series data. As for time series data, you don't want to mix samples from the future with the samples from the past because you are dealing with time. Okay. So Jayan says coding around a language root low type Chesina test case fail ani ostundi assignment low avariki aina teliste chipandi please. The problem is I can read it but I don't understand. I believe you are saying if time remains it's explain the assignment or something. That's what you are saying. Hey, someone explain me English what he wrote. Okay. Try different numbers for estimators. So that is what we did here. We tried different numbers for estimators, right? And then we saw that, okay, when the estimator is somewhat 70, then we get 88%, which is far better than our 81% mark that we were getting. And note 81% we are getting on default 100, right? So when you increase the estimator size number, then we are basically also losing. And when we are decreasing, then also we are losing. So we need to have the right balance. Okay. The test cases are failing in assignment even if we are trying different languages. I'm sorry, I just write the questions. I don't prepare any of test cases or whatever. I believe you need to, yeah. So anything assignment, Abhi will help you. Blackbucks Abhi will help you. Okay. What else? What else? What else can we do? Um, so we did this. We also did our model scoring and so on and so forth. So, okay. Yeah, we did our model accuracy, right? And everything is cool. Now, what else can we do? So this is basically up until now, I explained you a lot more on detail what we covered yesterday. Yesterday I rushed it. Today I explained it in yesterday I'm saying on Saturday I rushed it, but today I explained it a lot more in detail. And I believe you should have a very good idea of how it is working. Okay. Okay. We use pickle to just basically save our model, and with our model actually we can reuse the same model. Okay. Now what's next? Um, this is basically okay. So what are we doing here? What are we doing here? Right? We basically imported a cross validation score. This is what we wanted to check. Cross validation, right? To measure the result, okay, across 5 different training and data sets. I said that we need to rotate and basically check and so on and so forth with different sort of estimation and data set that, okay, what is working the best and is it working fine or not? So we use different sort of estimators and then we see, okay, what we are getting. For example, in here, we tried with 100 estimator, 86% is model accuracy. Okay. And then we do five-fold in here. Okay. Basically, we measure mean cross-validation score across 5 different training and data set. Okay. Training and test set. That is what we are doing in here. And that is what it is giving us a score of. Okay. We get a mean score. So that is 82%. Then we get model accuracy 83%. We get cross-validation score of 81%. Then we do 85%, 83%, 86, 83, 86, so on and so forth. Okay. Okay. So again, to explain, we imported cross-val score. This is coming from Scikit-learn. Okay. And to measure the results across 5 different training and test sets. Okay. And we can achieve, we actually achieved this. We achieved this by setting our CV equals 5 and giving it this model. Okay. I just reinitialized it. Earlier we were using CLF. Okay. Giving this model and so on and so forth. And it works. Okay. Where X is the full feature set, Y is the full label. Okay. Obviously, X is the full feature set, Y is the label. Okay. Set. And CV is the number of train and test splits. Okay. That we need to cross-validate. And this will be created automatically from the data via Scikit-learn. Okay. I hope it is clear. Okay. Now we need to see, once we run this, we need to see which model has the best cross-validation score. Okay. We need to see which model has the best cross-validation score. And this is usually a better indicator of the quality model than a single split accuracy score. So whatever we were measuring earlier, which is single split accuracy score, having a cross validation score is much better. Okay. Now, rather than setting up and tracking the results of these experiments manually, now because this to track all of this manually is cumbersome task, right? What we can do is Scikit-learn again provides us with a newer function. It's called grid search CV. Okay. It's called grid search CV. It is a way to search over a set of different hyperparameter values and automatically test which performs the best. So how can we do it? Okay. How can we do it? Okay. This is the way we can do it. So what are we doing here? We are basically creating a random seed. This we have already seen how to create a random seed from NumPy, correct? And then we import grid search CV from Scikit-learn. Okay. In here also, from model selection Scikit-learn, we imported cross-validation score. From Scikit-learn model selection, we are importing grid search CV. Okay. Then we need to define the parameters to search over in dictionary form. Okay. And these can be any of your target models parameters. Primarily, we have been using what? An estimator. That is what we'll use here. Okay. Then we are saying range from 100 to 200. That is what we did here. That is what we did here. Right? In here also, we were ranging from 100 to 200. So in here also, we are ranging from 100 to 200. Okay. And then stepping over 10. Then how does grid works? Okay. How does grid works? Grid search CV needs to have estimator. So basically we are saying we are using random forest classifier. Okay. This is the model that we are using. Correct. Then we are using param grid. So grid is what? This is the grid. This is the estimator. This is your grid estimator. That is what you need to provide in here. Okay. Which sort of should be a range or something. Okay. That needs to change. So that's how you set grid. Okay. Then you are saying on 5 different training and data set, just like how you did here, I need this to be evaluated. That is why you set CV to 5, and then you wanted it to be verbose. Okay. Now let's just print it. And then we are, okay. At the end, we are also fitting it. The fitting works just like how previously we were doing. Okay. Now what it is saying, based on all of this, fitting 5-fold for each of 10 candidates, totaling 50 fits, the best parameter values are an estimator 120 with the score of 82.82. We can also play around with this. Let's just say we want to have this to be set at like 10 to 100, and let's see now 82.84, and in here it says 100. Maybe we want to give it up until 500. Okay. Now it calculates for 245 fits. It is taking time because I think so it's a lot. Right. And it says the best estimator is 200. Okay. Across all of this thing. So now we know, okay, 200 is the best estimator, okay, with a score of 83.48 percentage. Okay. With a score of 83.48 percentage. In here, we got a very similar sort of value. I mean, in here, we were earlier it predicted 120, which was also okay, because in here also we are getting 120 when we are doing cross validation manually. Okay, but we have increased this to calculate from 10 to 500, and there it gives us 200. We didn't even reach 200 in here, so that's also fine. Okay, so this is how you can do cross validation. Okay, this is how you can do cross validation. Cool. Now what you can do, you can basically extract the best estimator out of it, which is estimator 200. You extract this. So when you say grid, you already have grid. You did all these fittings. Now you got the best estimator. You did this, all these cross validation and so on and so forth. And now why you did it? To get the best hyperparameter for your classification. Okay. So you got the best one out of it. And then now you repeat the process. You repeat the process of training and so on and so forth. Right? You repeat the process of training and stuff. And then you find the best model score on single test split now. Okay. So what is the best model score on single test split? They are getting 85.25%. So this is what we are getting, which is good enough. Cool. Finally, the same thing, you can use pickle. Where is pickle? Where is pickle, man? Right. So you can use pickle and you can save it there, something like that. And you can reuse it. Okay. If you remember, you can just dump your model, which is CLF in here. You can dump it and basically say, okay, save it with this dot pickle. and then you can load it via pickle load and type the name of your pickle file, and basically then you can get the score. Simple. Pickle is an inbuilt library that you can use in Python. Okay. What else? What else? If you have a larger model, okay, if you have a larger model, then there is something called as job lib. Okay, job lib that you can use. Okay, I won't run it, but I'll show you. So this is how you can dump job lib model, and I don't know if it's work. Okay, yeah. This is how you can use it, job lib, and but use it only for large model. Okay, pickle is very sufficient for smaller models. Okay, and then you can again use job libs function to load, and you are loading, and basically you try to get the prediction. Cool. Works. All good. Okay, we are getting 86.89% because we save model, not CLF. Do remember it. Okay. Now, I think we have covered a lot of stuff up until now. Up until now, anyone has any doubts? Okay, you don't. Cool. I assume I explained everything nicely. So give me good feedbacks. Cool. Because you are not asking me questions. Okay. Um, so few steps that you always need to follow. Okay. One, okay. Okay, wait. So first thing that we need to know is in Python, data does not always come ready. Okay, data does not always come ready. Okay, to use with libraries like Scikit-learn. Okay, so some steps that you always need to take care of. Always is not the right one. Maybe often you need to take care of. Okay, so one is what? Splitting the data into features, right? Splitting the data into features. In here, usually X and labels, usually Y. That's one, right? Then what? Splitting the data into training and testing data set. Splitting the data into training and testing data set, and possibly also a validation test. Sorry, validation set. Okay. What else? Filling. Okay. Filling, or also called imputing, or disregarding missing values. So we need to take care of missing values. Okay. Finally, convert non-numerical values into numerical values. Okay. So converting non-numerical values into numerical values, also called as feature encoding. Okay. So these are the steps that we will mostly follow. Okay. Now let's see. Uh, we have done the heart disease stuff a lot now. So okay, let's start working with a new data set. Okay. I actually so give me 1 minute here. So 1.1, like let's make sure today's topic is basically juice making process from farming products. Okay, let's make sure it's all numerical. Okay, so one, we know that computer works with numbers, right? It can be binary, decimal, whatever, but computer in general understand numbers. Okay, so one thing you'll often have to make sure that your data sets are in numerical form. Hence, you need to make sure that your data sets are in numerical form. That means quantifiable. That means measurable. Because how you'll do any sort of prediction, you need some numbers, right? You need to chunk numbers. That's how we are predicting. Okay. For example, in our previous one, okay, in our previous data set, we were working with heart rate, right? All you see is numbers, right? Age, sex, so on and so forth. Right, we are dealing with numbers mostly. Why are we dealing mostly with numbers? Because it's just much more easier. That is one. Secondly, it is quantifiable. It is quantifiable. That's the second reason. Okay. Um, okay. Let's work with car sales data set. Okay. I have a car sale data set that we were previously working on, but now this car sales data set is basically extended. Guys, tell Harshvardhan today's topic. Fast, tell him today's topic. Just now I said what is the topic. Tell him. Hmm. Need to see where is that? Car says, Scikit-learn data. Okay. And car says extended. Okay. So this is what we need in here. Okay. And let's see now. So if you see, it has 1,000 rows now. So earlier we were having a smaller data set, but now this data set that I have, it has 1,000 rows. So we have a lot of data that we can work with. Okay. Now what can we do with this? We can basically check data types. How we used to check data types? We used to say car sales dot d types. That's how, right? Um, in here, if you notice, make and color features. Okay, these are features, right? These are features. So make and color features are of object data type. That means there are strings in here. Where is the rest of the column? Rest of the column are what? Are in 64. Correct? I polished it in our earlier data set. We were having $sign. That's why it was taking it as the string. But now because that's not there, it is by default taking it as int 64. Okay. What is the first thing that we need to do? Now you guys will start guiding me. Quickly write it. What should I do now? What should I do now? Hey, why would I convert object to uh, for now at least? Why? Later on, we will turn them into numerical form, but not now. You're right, but not now. Teachers and label is also wrong. I mean, it's right, but you need to tell me like first step, just before it. It is all right, but it is not in the order. Hey, there is no missing values, man. I say it has missing values. No data pre-processing. Correct, Saujanya. Splitting data set. We need to split it, right? We need to split into X and Y, that is features and labels, and we need to split it into our training and test data set. Okay. So, what do we want to turn into label? Maybe let's say we want a label as mm, random, what I'm saying, label as let's say label as price. Price is what we want to predict. Okay. So what we'll do? Drop, right? Then price. Then what we'll do? Axis equals 1. Okay. And Y, which is our label. Okay. We'll say price. Cool. And we can see X and Y. There. All good? All good? So I assume all good. What else? What should I do next? What should I do next? What should I do next? Correct. We have to select model. First, we need to decide what model we need to use, right? We don't even know, okay, what model we need to use. So what we need to do, we need to go in here. Okay. We need to go in here in our map, and we need to understand, okay, what sort of model can we use? First of all, let's start here. Do we have more than 50 samples? Yes, we do have more than 50 samples. Okay. Are we predicting some sort of category? Technically, no, right? We don't have any binary category in here. That, okay, this type of car, that type of car, sedan, we don't have any categories. So, no, we don't have categories. Are we trying to predict some sort of quantity? So, if you see, yes, we are trying to predict some sort of quantity. Price can be considered a quantity. If we are trying to predict a price, so we are trying to predict some form of quantity. Okay. Um, what else? What else? Do we have more than 100K samples? Sorry, less than 100K samples. Then yes, we have less than 100K samples. Features should be important. Yes or no? Okay. So yes, no. And in this part, no. Hence, at least we know, okay, this does not cover everything, but we have some idea that we can use what? We can use what? What sort of model we can use? Tell me what sort of model we can use. Regression. We can use regression. Correct. Okay, we can use regression. That is correct. Hmm. Now, I am thinking what sort of regression should we use? So, hmm, let's see. Let's see. Okay. Hmm. Um, let's go to car sales. Now start guiding me what I need to do in here. I'll just select the model. So from sklearn dot ensemble import random forest regressor. Okay. This is the model that we'll use. Okay. Random forest regressor. This is the model we are using. Now what we need to do? Now what we need to do? What is the next step? Next step. Oh, sorry. This is wrong place. Car sales. Oh, we missed another step before this. So let's do that before that. So firstly, we need to split, I said, right? So we need to split, we'll split. And that's how we split it. Okay. And now, what should we do after this? We chose our model. What should we do? Okay. Train, that is very vague, but we need to fit. So model dot fit. We need to do fitting, right? We have our training data, correct? So which is correct. We need to train the model, but the step is fitting. So we need to fit the model. Okay. Boom. And yes, we are getting XYZ sort of so many errors. Okay. Why is that? Why is that? Why are we getting this? Any idea? Any idea why? Why? Why we always is used a small letter, man? That's label that doesn't change anything. It does not work. Okay, it does not work because we will have to convert the non-numerical features into numbers first. Okay, that is why it is not working. That is what I wanted to show you. If we have everything in numbers, it will work by default, but we don't. The and henceforth we need to convert string type of data into numbers using encoding. Okay. Now Scikit-learn has its own guide that you guys can actually look through. It's called Encoding Categorical Features. I won't go much in detail, but you can read the library. Okay. Uh, but the most straightforward one that we will cover is one hot encoding. Now in machine learning, one hot encoding gives value of 1 to the target value and a value of 0 to the other values. Okay. So for example, let's say we have 5 samples, right? Which is car sales. Okay. So we have this Honda, BMW, Toyota, Nissan, and so forth, right? So we have these values. Okay. If we were to one hot encode, if we are to one hot encode, then what will happen is assume now how should I show you? Assume we have sample. Okay. We have sample. And then we are saying we have Honda and we have BMW and we have Toyota and we have Nissan, right? And we are saying this is 1, 2, 3, 4, 5. Okay. And we are saying, okay, one, do we have Honda? Yes, we have. We don't have a BMW, we don't have a Toyota, we don't have a Nissan, right? Same goes here. Two, do we have a Honda? Do we have a Honda? No, right? Do we have a BMW? Yes, we do. We do. Do we have Toyota? No. 0, 0. Right. Then again, do we have a Honda? 1. BMW? No. 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 Same here. 0, 0. And we have this and 0. Okay. Then again here. Nissan is the only thing that we have 0, 0, and we have this. Right. When you click it, you will see it. Forget about this. Or maybe I can make this something like this. Yeah. Okay. So that's how one hot encoder works. Okay. Now you will notice how there is 1 for each target value, but 0 for all other values, right? So that's how we can use. Okay. Now, how can we use it? So Scikit-learn, basically from pre-processing, we can import one hot encoder. What is another thing that we need to import to achieve and transform is to get a column transformer. That is also something provided by Scikit-learn. What it does, it targets specific columns of a data frame and transforms it. Okay. And it defines the categorical features that we'd like to transform. Okay. So let's try to do it one by one. So step one, import it. So we get one hot encoder, column transformer, correct? Right. Then what else? We need to define, okay, the categorical feature that we want to transform. Okay. So assume we want to transform make, color, and doors. Okay. Then we need to create an instance of one hot encoder. Home. Okay. Now, step 4. Step 4 is when we will do our column transformer. Okay. So we use column transformer. We say its name is one hot. We define our transformer, basically use this encoder, this type of transformation that you will be using. Which columns we want to transform? The categorical features that we have said, that is make, color, and doors, and remainder pass through. Okay. So what to do with the rest of the columns? Basically leave it unchanged. Okay. We don't want to transform it. Okay. That's what we are saying. Hence, we create a transformer. Okay. How do we transform? Now, we need to create X for our transform feature set. So that's how we create it. That's how we create it. Transform dot fit transform. Up until now, what we were doing? Just using model dot fit. Now, because we have to fit on the transform data, we are saying transformer dot fit transform, and then we get this. Okay. Now, you might be thinking why we consider doors as a categorical variable. Correct? Because that was already a number. And in here we are using doors. No one asked me this. Why are we using doors? Even though you are having make and color, and we said that we want to transform objects into numbers. So you should have asked this question, and it is also anyways a valid question. Okay, but doors is already numerical. Okay, the answer is doors can be numerical or categorical. Okay. However, in this case, I have decided that doors would be categorical. Okay. Since number of doors is often different category of car. For example, you can have 2-door car, you can have 3-door car, you can have 4-door car. So there are different types of car, and it is not necessary that you always have 4-door car or something. If you go for Tata Nano or you go for this small NG car, you get 2 doors. Okay. There are some single door car as well. So there can be different number of doors for cars. Okay. And some cars also have 5 doors. For example, your Bolero or something, it has 5 doors, right? 4, and then a back door, 5 door. Because you have sitting in the back place as well. Okay. That's why it is a category. What is category? Why are we doing, why I keep calling it category? Because it is a categorical feature. We already know that, okay, this is the category that we can divide it into. Honda, BMW, Toyota, doors, 5 door, 3 door, 2 door, white, blue, black. Okay, it has a very finite set of categories that can be divided into. While price and odometer are not finite, it is weird, it is off. It is not a proper categorization. Okay, now let's see. If we do x head, cool, we get this, which is fine. Okay, but if we want to get transformed x0, this is what we get. Okay, what were these values originally? If I want to see what was the original values of these values, then I can do iloc. Now, can someone explain me what is iloc? What is iloc? Past. We did this already. iloc. What is iloc? This is from pandas. Position, index, location, correct. Okay. Correct, correct, correct. A more detailed answer is specifies the data at that position. All of you are correct, right? So that's what we are getting in here. This is what it is signifying. Honda, white, odometer, so on and so forth. Okay, that's what is there in this 0th position. Now, 1.1.1. Cool. Numerically encoding data with pandas. Okay. Well, how else can we encode? Okay. So there is another way we can do it using pandas. Okay. So we can use get dummies. Okay. Get dummies function method and pass it to our target columns. In return, we'll get a one hot encoded version of our target columns. Okay. Now, I'll just write it for you guys. Okay. Right. Okay. Now, if I want to see car sales, if I want to see car sales, this is how I can see car sales, which is cool. Okay. If I want to now get one hot encoded data variable, okay. If I want to get one hot encoded data variable, boom. What did I do here? I said my categorical values are make, color, doors. Okay. Now give me dummy data for car sales and make these as categorical values. And hence what it does, it generates one hot encoded data. In here, true false is nothing but 1 and zeros that I showed earlier. That is what it is. Okay. It's just generated in a nicely formed data frame. Okay. And you can see how we have a column for each category. So BMW is one category, Honda is one category, Nissan is one category. Okay. We have so many different sort of columns. Okay. But you will notice that how it missed doors. The reason is because doors is already numeric. Okay. So for pandas and get dummies to work on it, we can change it to type object. Okay. By default, get dummies will turn only objects. Okay. and it turns everything into true and false only. That is the default setting. Okay. So we can get return values at 0, 1 if we want by setting data type to float. So how can we do it? How can we do it? It's very simple. Car sales, doors, car sales, doors. We are changing doors to what? Object type. Okay, which is obviously in here string type. We say get data, car sales, make, color, doors, and the data type should be float. And now let's see, and we get 0, 1, 0, 1. And we also have different types of door, 3, 4, 5. These are different categories. Nice, right? Pretty nice. So we have now turned our data into fully numeric form using Scikit-learn and pandas. Now you might be wondering, should you use Scikit-learn or pandas for turning data into numerical form? And the answer is you can use either. Okay, but there are rules. If you are performing quick data analysis and running some sort of a small model experiments, then use pandas. Okay. So for your testing purposes, small data sets, you can use pandas because it is very fast. Okay. It is very fast. But if you are performing a large scale modeling experiment, you are working with large data set, doing something in production pipeline, working for a company, it's ideal to just use and recommended to use Scikit-learn, especially Scikit-learn pipeline, chaining together multiple estimators and modeling steps. That's how you are supposed to do. Okay, Scikit-learn pipeline basically chains multiple estimator and all this modeling and all these things that we do. You can read about Scikit-learn pipeline. Okay, for our use case, because we are learning, pandas is good enough. Though I showed you both ways, and there are also advanced encoding techniques. We are just doing the most straightforward one. Okay. Now, since we have turned our data into numerical forms, now what can we do? We can actually recreate our model and stuff and like split data and everything, right? We can redo it. So let's try to redo it. So we do some sort of redoing in here. We are doing the test training split. The same thing here that we'll use we'll try to fit X train, Y train, so on and so forth, right? And then we'll try to get the score. Cool. So we got the score, we fit the model. We also basically used a regressor model. We split the stuff, okay. And so on and so forth, right? In here, you can change hyperparameters however you want to change. For today, I'll stop here. Okay. Tomorrow, we'll start working on missing parts. Basically, we'll have another data set where we are missing data on the car sales value. And then we'll try to look more deeper into regression. Okay. There is a lot to cover, but I am hoping to at least complete Scikit-learn tomorrow and then start off with yeah, at least then start off with deep learning. It will, yeah. Oh, who is asking me today's topic? Today's topic is How to produce fruits via organic farming. Fruit cultivation via organic farming. That's topic name. Now I know who are the people who give me lowest scores in the feedback portal. They are all these people who ask, what is the topic today, sir? At the end of the class. So any questions for this class up until now? I'll basically stop. Topic name is I'll type it for you, man. Fruit cultivation with organic farming. That's oh, I did a DM or something. Wait. That's the one. HPX 360. I'll share my notebook anyways. Maybe you missed something. That's why you are getting error X is not defined because I'm getting it. Okay. And if I am getting it, you are not getting it, that means you missed something. No questions, guys. Am I so amazing? I'll send the notebook. I'll send it after tomorrow's class, though. I won't send it today. I'll send it after tomorrow's class. HP 360, make sure that you have initialized X because I have initialized X and Y, which is features and labels. That's why it's working for me. Comparison with pandas of what? Scikit is hard, man. Yes, it's hard because it has. See, actually, all of these are very easy. There is no logic involved, to be honest. Uh, some logic is definitely involved because now you are getting so many tools uh, and you are getting so many functions and features. The thing is that you need to remember the hardest part is that you need to remember how you will utilize all of these things like cross validation and features, labels, how you will do prediction, how you will choose models. These are the hardest part to understand. That is where the whole logic is. Okay. Apart from that, everything is just function. Easy way to understand and learn scikit-learn is try yourself. That is the easiest one. Okay. Yes, it won't work HP 360. It is not working because you didn't split the data into features and label. You need X and you need to initialize as features, right? Let me share my screen quickly. I'll show you. See, see here, I say split into X and Y, training and testing data, X, Y, X, Y. That's where I'm getting X and Y from. You are not doing this. Okay. So easiest way to learn is try yourself. If you will try yourself, I think it is the right time once we complete Scikit-learn, try diving into Kaggle. Okay. You will learn a lot. We are still learning Scikit-learn, even in the next class. Probably even in the class after that as well, we might still be in Scikit-learn. It's a very long part actually. How much time it take to Scikit for learning for models? Depends. How large is your model? It completely depends on it. How large of a data set you have. For example, if you are providing it 3 GB, 4 GB of data set, it might take even 15 minutes, 20 minutes. Sometimes it might take 3 hours. Sometimes it might take 5 hours. It completely depends on the amount of data set that you are actually passing it to. If you will open up, like there is a model Hugging Face. It is a LLVM based model. For training, it takes at least 6 to 7 hours. You can use your models in a web application. Everyone uses it. You need to pre-train it, right? It is more like you already trained your model and then you are getting predictions out of it instantly. No one actually uses their model and train their model when an end user is using it. They pre-train it and then get the value out of it. Do we have to memorize? No, you don't have to memorize any syntax. What you need to understand, what we need to use. For example, we need to do cross validation. We need to convert features into numericals. These are the concepts that you need to memorize, because you can just look up the keywords and syntax yourself on Google, right? For example, encoding, you might not even be using this encoding that I am doing. You might need some other form of encoding. So, but you need to know that you need to use some sort of encoding. That is important. I don't know, man, how many is left. Depending on how many sessions we have left is also will also decide how much in depth I'll go for deep learning.